that day, I will turn back the paper copy you turned into me in your filing cabinet. And what I would like for you to do is to figure out which questions that you missed and correct those for points. Okay? Now, a correction, and I'll go through this formally on Wednesday, but a correction includes why your answer is incorrect, the correct answer, and then a reference for where you found the correct answer. You with me? So, if you do that, you get 50% of the points back that you missed. Now, I'll also say that you guys did really well on the exam from a chemistry professor's perspective. You guys were right at 80% as an overall as a class. Okay? So, for me, I would prefer that the average be at 75%, because then that's right there in the middle of the C where you're supposed to be, right? You guys catch the winks on that? I'd rather it be higher. So, anyway. Cool? You guys with that? All right. So that assignment will be probably made Wednesday, just to let you know it's coming. All right. I reopened chapter 3 yesterday, a day ahead, because somebody emailed me and said they really wanted it open. So I went ahead and did that so they could work on it. So chapter 3 is open now. Any other housekeeping? Did I put up a lab quiz on Friday? Or is it still not available? I literally forgot to do that until just this moment. So, will you guys read lab this week?
Yes.
And go to the handouts and print off the lab handout before you come to lab?
Yes.
Okay, no lab quiz this week.
Thank you.
All right, since I forgot to put it up over the weekend, that's my bad. All right, no lab quiz this week. So, but you have the responsibility to go print the lab handout and reread, yes.
Is there anything from the last class that we need to have done this week?
No. The last week's lab you don't have to have done this week because you have to weigh your product, right? And then from your weights of your product, then you will make some conclusions. Cool? And so the lab will be due next week. This week's lab, the ester synthesis lab, is actually 2 weeks long. Okay? And so this week we will synthesize. And then next week we will actually do spectroscopic analysis, melting points, those types of things. Cool? All right, so this week's lab is 2 weeks. So nice to see everyone's face. Okay? Most everyone's face, right?
Have you ever seen him before?
Some of them, yes, a lot. Right? Some of them a lot. Others, no, not at all. But it's nice to have people and you can see expressions. So now's when I can really figure out how much you guys dislike me, right? Individual atoms in a compound. This is where we quit last time. I think we were working and we were going from moles of a compound through a chemical formula to moles of atoms. We were using Avogadro's number to do number of atoms. In fact, we did one of those on the test. Okay? Actually 2. One of them I made a little bit more complex than the other one. And so, did we do this one? We did finish that. And so we were then getting ready to start on molar mass, right? And begin an adventure. This is my favorite part of chemistry. Okay? Stoichiometry, and the uses of that to do real chemistry. And the mathematics can get quite complicated in thermodynamics, but in reality, yeah, it's very useful and actually can be fun. I know that. Does anybody like to do puzzles like Sudoku or those types of things? To me, stoichiometry is in that same fashion, right? You start seeing patterns and you recognize them, and I know that may sound crazy, but it's really the truth, okay? And then especially when you get into equilibrium mathematics, then they just become complex puzzles to solve, and it can actually give enjoyment to some crazy people in the world like me. All right, so anyway, this is just showing the atomic mass units in a gram in terms of, or what 1 mole of atoms is then expressed in grams. And so anyway, what that atomic mass unit is in grams, I guess is the way to say that. And so anyways, just giving that as a picture. We don't use it in that form very often. Really what we do is we use conversions, okay? And all the conversions that we do are actually based on the relative weight of one isotope of carbon, carbon-12, okay? But what I'm showing up here on the board is the atomic mass of carbon. And the atomic mass is actually a ratio of isotopes, a weighted average actually is what it really is, a weighted average. And so that weighted average is from the common isotopes. And the most likely isotope you guys gave me on the quiz when I have 12.011 would be what? Carbon-12, right? And so that's the correct answer for that one. But anyway, how many moles of aluminum are present in an empty soda can with a mass of 13.9 grams? How many moles of aluminum are present in an empty soda can with a mass of 13.9 grams? So I'm starting with 13.9 grams of aluminum. Would you guys agree with that statement? That's the beginning of a calculation. 13.9 grams. And I always write what it is with that, okay? Because it identifies, okay? And in that identification, then if I convert to some other element from a stoichiometric ratio, then I can cancel the element that I'm going from to keep the one that I'm going to. Does that make sense? Yeah. And so anyway, so always get in that habit. And so 13.9 grams is asking for an answer in moles, right? Would you guys agree with that statement? So it's saying to convert to moles of aluminum. And so now I need the conversion factor. Where do I get it? Right on the periodic table. And so this is actually atomic mass instead of molar mass, right? Well, I guess molar mass is correct in that, but not for molecular, right? Because it's an atom, and so element aluminum. But I pull that right down. What number am I going to use? 26.98. Now, that statement on the board, that 1 mole of aluminum is equal to 26.98 grams of aluminum. Would you guys agree with that statement? That's what that number on the board up there says. Okay? And then I use the same philosophy to figure out, I want to cancel grams, so what's going to be on top? Moles, right? I want to convert to moles, so so I set it up in this fashion. I cancel units, grams of aluminum, I'm left with moles of aluminum, and so then I would evaluate that numerically. Now, what did you notice I did first? What did I do before I did the numerical evaluation? Dimensional analysis would be the answer to that. Okay? I did the dimensional analysis first to show that I had the proper units before I actually got my calculator and punched a button. Did you guys catch that?
So dimensional analysis is like setting it up in the way it should be set up to cancel?
Exactly. That's all it is. That's a fancy word for something that is very simple in practice. Okay? And do I want that when you guys do mathematics? Yes, I will award you extra points for that on your tests. I promise. Okay? Yes. On your lab, same way. Lab handouts when you're making observations and calculations. Put those units on there. Please, please. Okay? It will benefit you. All right, so the answer to this is 0.515 moles of aluminum. Cool? Huh?
I said neat.
Neat. All right, ooh, we can use the word neat. For some reason I thought of Monty Python right there. There's got to be some kind of skit to do with that. All right, molar masses for compounds, right? So this is two examples of molar mass for compounds. I set them up a little bit differently. I've shown you guys how I would do that. I would say that there's 1 carbon and 1 oxygen for the first one, and then multiply that times 12.011 grams per mole for the carbon. and this would be times 15.999 or 16, and so this would equal 12.01, and this would be 15.99, and then I add down, okay? And so I set mine up. That's the appropriate way to do it algebraically if you want to see it up there. Okay? So, but this is the way I set mine up. It's just convenient. Does that make sense? And so anyway, it allows me to identify each element well and so on. And so anyway, if I get to the answer of that, then it's 28.010 grams per mole CO. And now, what have I calculated there? What did I calculate? If I ask you that on a question, what is that number 28.01? You might say it's the molecular weight for carbon monoxide, which is correct. But what am I really asking? What am I asking? What is that number used for?
How many grams per mole?
Grams per mole. It's what I'm looking for is conversion factor. Right? You guys get that? That's so we can convert from grams to mole or moles to grams when we have an amount that we're working with in a measurement. It's a conversion factor. All of those atomic weights on the board should be defined as conversion factors. Okay? Because we're going to go somewhere else with them. We're going to drive places. All right, molar mass. All right, what's the molar mass of acetic acid? All right, you guys calculate this one. Molar mass of acetic acid. I have a quick question as you're starting this. How many total hydrogens?
4.
Total of 4. There's 3 in one place and a 4th in the other. Why is that one written separately from the other 3?
It's an acid, so it needs to go in the front.
It's an acid, so it is separated from the non-acidic hydrogens. Okay? So it's separated from the non-acidic hydrogens. And you'll often see in organic where that's written after, too, where they flip the order of those. And I don't know why, but they do that. You ready to mental math that one? 4 plus 24 plus 32. Right? 4 plus 24 plus 32. Do we do that a lot as chemists once we kind of get this down, or we will truncate those significant figures and just do a approximation? Yeah. All right, so 60.52 grams per mole. 60.5. Everybody good? Did you guys get that? Or am I ahead of you? Did I go too fast? Oh, went too fast. All right, I'll slow down on the next one. There'll be more opportunities. Oh gosh, we brought back stuff from earlier in the chapter, didn't we? Calculate the molar mass of calcium sulfate dihydrate. All right, I want you guys to write down the formula from the name right now. See how you do on that. We'll start there. calcium ion is Ca2 plus. Yep, that's correct. Sulfate ion. Let's get that one. SO4 2 minus, correct? And then hydrate. How many people are going to use H2O for that? Yeah? So now can we write a formula out of this? CaSO4 2H2O. How'd you guys do? Yeah? Now calculate the molecular weight. Now calculate the molecular weight. Practice. Now, I may do this differently than you guys. I know the molecular weight of water and it's 18, and so I always just keep waters together and multiply the number of waters in the hydrate times 18 instead of taking out the hydrogens and putting them with the other hydrogens and the oxygens and putting them with the other oxygens. Could you do it either way? Yeah, it's just like driving to Hollister through the dam or just driving down the hill, right? And so either way works. So there's the formula. All right, how you guys doing? Do I need to wait? Still calculating? All right, nobody said no. 172.16 gram per mole. 172.16 grams per mole. Calcium sulfate, 2H2O. Not much room to write there, do I? How'd you do? Good? We got this down? Is this something you guys practiced in high school? Yeah, probably got pretty good at these. Nope.
It's a long time ago.
Oh. Hey, I graduated from high school and then went to college 9 years later, so I know that feeling. Still was able to do it though. All right, the molar mass of a compound can be used as a conversion factor. Wait a minute, isn't that what I said?
Huh?
Molar mass is a conversion factor. Yeah. Somehow, moles of compound to molar mass to mass of compound. Moles to mass, mass to moles. And so anyway, how many moles of NaCl are in 0.30 milligrams? 30 milligrams. Can I teach you guys a little trick right now? So it's given that we have two choices. We can convert the milligrams to grams if we would like. Or can we convert the conversion factor? Yeah. And so the first thing I need is give me the molecular weight of sodium chloride. Calculate that very quickly for me. You guys got it? 50, what? 58.44 grams per mole NaCl. I have a question. Is this the same value? That's the same conversion. It is, isn't it? Except all I've done is change both terms by a factor of 1,000, right? You guys with me? And so this gave me in milligrams, so I'm just going to use a millimole conversion and give the answer in millimoles if I can get away with that. Right? Catch that? Fun? Yeah, I think. So 0.30 milligrams of Na times, no wait a minute, is this correct? Did I set this up properly? If I did my math right now, what would my units be? They'd be wrong. Good answer. They would be milligrams squared by millimole. You guys catch that? I just did the math. So I evaluated my units, and guess what? I set it upside down. Oh, and so when Dr. Garrison does that, one of the reasons why I don't use those neat little nifty brackets that you guys use, right, is because I just take a line and go 1 over, and now I fix the calculation. Yeah? And so now, when I do that, that millimole moves upstairs. My milligrams now cancel, and my units are millimoles NaCl. Cool? Which is what we were looking for, isn't it? Yeah. What did I evaluate first? Units or the numbers? Units. Okay.
Once you find the answer, can you just convert that back to normal moles?
Oh yeah, if you need to, yeah. So very often when someone asks the number of moles, I can give that answer in millimoles. It's this, in my mind, it's the same thing. It's just different by a factor of 1,000. So it's just a prefix which shifts that because I'm talking about very small amounts, and so it's better to report that in milli instead of moles. Makes it a more usual number if I'm doing 0.3 milligrams, right? And so let's look at that answer. And well, they gave it to us in moles, 5.1 times 10 to the minus 6, right? So what does that make this answer? 5.1 times 10 to the minus 3 millimoles. And so in my mind, those are both correct answers. Now on a multiple choice test, would you have to convert from there to there if the answers were all given in moles? And the answer is yes. Okay. But that's just another basic conversion, and we're all going to get really good at basic conversions. Okay?
Is like half of a regular mole?
Do what?
Millimole is like half of a regular
It's 1,000. A millimole is 1,000, 1,000 of a mole. So in other words, that what I'm saying is that 1 mole is equal to 1,000 millimoles. Right? It's just like a milliliter. How many milliliters are in 1 liter? Same. So that we all know that prefix, right? Milli. And if we did micro, what is it? 10 to the minus 6, right? What about nanomolar? 10 to the negative 9. And so, do I use all of those prefixes regularly? Answer is yes. Right? We use those a lot. So trying to convince you to learn them so that you can use them too. All right, converting between mass of a compound and number of atoms. So now we're combining what we were doing in the previous section to what we're doing in this section. If I start with moles of compound, to moles of atom, and then to Avogadro's number of atoms. Okay? Now, I can be honest with you, I don't do this calculation very often. I don't often want to know the absolute number of atoms. I know the value because I have the moles of the atoms, right? And to me, that's as far as I normally need to go. And this is just one more step. But when I'm doing analysis and those types of things, then it's not as necessary. So, but I still want you guys to practice it because understanding that is very important. And so here we go. We're going to start with milligrams of salt. I assume this is sodium chloride again. Yeah. 2 milligrams of sodium chloride to atoms of sodium plus chloride, right? What I would do is take that number milligrams, right? 0.30 milligrams of NaCl, right? That milligrams and convert to moles of NaCl. And then knowing the stoichiometric ratio for every 1 atom of sodium chloride, I have 1 sodium and 1 chloride, or 2 atoms to count, and then just multiply that number by 2 in a mole conversion. So, So looking something like that. Now, I want to say this the best way that I can. This is sometimes hard if you don't know how to do this. Okay? This can be hard if you don't know where you're driving to. Right? It really can. But when you practice this and learn the route, the different ways you can go, and you know the streets, then this really is a nice trip. Does that make sense? Yeah.
Isn't equals 2 atoms?
No, that's a times. That's my multiplication sign. I just kind of scribble those. I know. If I use X, and I write it just like my variable X, and so I use asterisks or scribbles. Yeah, for multiplication signs. I know. So I don't have the answer up here, right? I don't have an equal sign. There's an equal sign in the fall button or in that room.
Yeah.
But here I took this number and, oops, I should have said millimoles and milligrams, right? And so I converted this to millimoles. Oh my gosh, there's a power of 3 that I'm missing right here. I missed 3 powers of 10, didn't I? Anybody catch that? Why did I miss 3 powers of 10? Because I have millimoles is what I calculated right here instead of moles. And then I did my conversion of molecules and moles right here. Yeah, and so I'm 3 powers is 10 off. So I've got to add one more conversion. My gosh, I've made an error. Okay, would I have caught that when I went through into dimensional analysis? Oh, wait a minute, what was I doing when I caught that? I was doing dimensional analysis. I would say I converted from milligrams, and then I noticed that this was moles, and I changed that to millimoles. And when I did that, then I knew that I had not correctly canceled right here. And so I'm trying to show you why I do that, because everything looks pretty good right here, and I would be off by 3 powers of 10. Okay, so I'm going to have to put another conversion in there, and that conversion would be what? For every 1 mole, right, of NaCl, right, then I have 1,000 millimoles. And so I have to put that conversion in there too. Oops.
So are there 2 atoms in?
So there are 2 atoms in the formula NaCl. There's a sodium atom and a chlorine atom, and so that's that conversion down there.
Gotcha.
I think I'm doing this. It's actually how many atoms of are in 0.3 milligrams of salt, so I'm assuming it's wanting both the sodium and the chlorine atoms, right? Or chloride, if you want to say it that way. And so here's what we have on the board. We have our calculation to get, oh, that's interesting. Yeah. Oh, yeah, that's right. So we could have just taken the one above because it's the same amount. 5.1 times 10 to the 6 moles of Na times the 6.022 times 10 to the 23rd to get the atoms of sodium, and then multiply that times 2 to get to the total atoms. Yeah. So did I approach that a little differently? Yeah. I have a question. Is 6.2 times 10 to the 18th atoms a lot of atoms? Yeah, that's a pretty big number, isn't it? So, ready for another one? Well, we get vocabulary. All right. Atomic mass. The average mass of an atom. Okay, the average mass of an atom. Molecular mass is the average mass of a molecule. Formula mass is the average mass of a formula unit of any type of substance. And so formula unit is the base, for example, this is a formula unit right here. Okay, and molar mass is the mass of any of the above using the same numerical value but expressed in grams per mole. Which one do we use? The bottom one. Okay, I'll use all of them, but in reality, for the stuff we're doing grams per mole in our calculations that we do. Okay, instead of atomic mass units, U. All right. Ready for percent composition? Total mass of an element in a compound divided by the total mass of the compound equals the percent composition for that element. Okay, calculate the percent composition using formula masses or molar masses. All right, and then we're going to use percent composition as a conversion factor between the component mass and the compound mass. In fact, you get to do this for lab this week, okay? And this is actually the compound that you're going to use. That's it. Well, hey, hang on. I want everybody to write the name of that compound down. It's on the board right now. And it's CuSO4.5H2O. Write down the name of that. See if you can name it from the formula. Oh, just be quiet. I knew it was there, yes. No, it's if I can get you to focus on the formula, right? Because that's where most people look. Is that true? Or did you read the whole sentence? Nobody read the. How many people read the whole sentence? Maybe a third to half, something like that.
When you said write down the name, I thought you wanted us to copy down like
I do.
name written.
All right, because copper sulfate pentahydrate. Would you guys agree that's correct? Did I get it right? Yeah. So this is for lab this week. We're going to work with copper sulfate pentahydrate. And so I want you right now to calculate the molecular weight for copper sulfate pentahydrate, okay, because that's a number you need right now to find the number of grams of copper, right, in 20 grams of copper sulfate pentahydrate. In fact, not this week, that's wrong. Let's see, it was last week that we did the copper sulfate lab, right? Yeah, my bad. This week we're doing ester. But you still need this calculation for finishing your lab. All right, anybody have that yet? Check yourselves. $247? 49? I just was guessing. It's been a year. 249.62. Somebody confirm that. Yeah. So there's a couple different ways. What's our strategy to answer this? It's asking how many grams of 20 grams are copper. How are we going to distinguish how much copper is relative to the compound? So take this number, right, and divide it into the number of moles of copper that are present, right? For every 1 mole of copper sulfate, how many moles of copper? 1, right? And so if that's the case, then this mass relative to the copper mass should give us a fraction, right, of the whole. So if I look it up and I find copper at 63.55 grams per mole, right? And if I want to do that in a percentage, then I would do what? Multiply times 100, and that would give me the percent copper in that compound. Do you guys agree with that statement? Yeah. And I actually don't want to do that right now to solve this problem. What do I want instead? And all you math people, I'm going to say it out loud, the fraction. But now when I say the fraction, I want the decimal value for that. So math heads always get mad at me when I do that, because chemists, when we say fraction, we mean decimal. Okay? Did you just catch that? Almost always. Almost, I said almost. So anyway, what's the fraction? What is it? 0.2546. I could write that or 25.46%, right? I just multiply times 100, just to let you know that. But I'm going to use this value, okay? Because this is the fraction that's copper, and then if I know that I have 20.0 grams of Cu, SO4, 5H2O, times the fraction that's copper, 0.2546, then this will equal the mass of copper, right? .68. Ooh, we're a little off there. That's okay. I'm good with that. There's always error in that last digit. All right. So 5 is my fraction, and then 20.0 times 0.25 equals 5.09 grams of copper. All right, now, for lab, you guys are doing some of these same calculations, okay? You're going to compare the results from your precipitation, okay? All right, so you precipitated out solids that have either copper in them, or you're going to indirectly measure the copper through the barium sulfate. So you're going to do some of these stoichiometric calculations. But what you're going to do is compare the amount of copper you found in the amount of copper sulfate that you weighed out, and calculate a percent copper from that, and then compare it to the percent if it were ideal. Okay? So this is the theoretical percent, and you're going to see how close your actual percent is. Okay? And then tell me, based on the two methods, which one of those methods got closer to the correct amount. Okay? Cool? Yeah. So these calculations will be used in lab, just let you know that. Okay? Directly like this. Now, if you are struggling with these calculations, what do? A, panic?
Yes.
B,
Sorry. I'm excited.
B, come up to the chemistry department and get help in the study session or during the day? Yes? Okay, that is the correct answer, B. I'll just leave it up there. Okay?
Have C and fries.
C, none of the above?
Fries.
Oh, cry, no. This is not working.
The great thing about C is you can do that at the end one or the other, so like I'm just saying.
This is supposed to be fun. I was helping my daughter one night with chemistry at our kitchen table, and I made her cry. I didn't mean to.
What did you say?
I don't even know. I have no idea. So, something that wasn't correct, okay? So whatever it was, it didn't matter what the answer was. I said something that was incorrect. Yeah, really yeah. I haven't made either one of my boys cry yet. You never know. I did have my oldest son tell me that no, I could not contact the chemistry teacher at the high school to correct him.
That's funny.
Mr. Coons, yeah, I know Coons. Never mind, I won't tell. I'm on film, I'm not gonna give up whether I did it or not. So anyway, how many grams of methane, CH4, can be formed from 100 grams of carbon? How much methane can be formed from 100 grams of carbon? How are we gonna do this one? Where are we gonna start? What do we need? You need a percent carbon, right? 100 grams of carbon, or we need the percent carbon from the methane, right? And so then we can multiply that out to find that. So that's a great strategy to do that. I have a tendency to want to go through moles right here. All right? Is there another route to do this problem besides doing it by percents? The answer is yes. You can use one to check the other. Okay? So I'm going to try to show you guys both calculations. We may run out of time before we get done today. But I want you guys try to set that up, see how you do. Okay? How are we doing? I did that one in my head without setting it up. Is that okay? I really had to struggle not to write 58 on the board when we did sodium chloride, because I have done sodium chloride so many times that I had that molecular weight memorized, right? And carbon and hydrogens are really easy because it's 12 multiples of 12, but you can do most of those in your head, and then multiples of 1, and you can do all of those in your head, right? So hydrocarbons are nice to calculate. How we doing? What?
His poor face.
Interesting. You know, it's scary. I didn't know I was that scary. All right. So, in this case, we're trying to find the growth in a sense, and so for every 100 grams of C, 74.85 grams are carbon, and in that ratio. And so then when we multiply that out, then it's 133.6 grams CH4. And so we're looking, yep.
If they ask how many moles in that nature formula, would you just take that and strictly find by mole?
Here's the way I would, if I read that problem without being in this part of the chapter, okay, I've got about 2 minutes, I'll go through this. Let's go back to the problem. And here's the way I probably would have answered this. And assuming 100% yield, then we have the carbon's the limiting reagent. Oops, I had the question right there. Then I would have started with 100 grams of carbon, right? And then I would have converted that to moles times 1 mole over 12 grams. And so now I have moles of carbon. And then for every, I need a mole conversion right here. For every 1 mole of CH4, then I have 1 mole carbon. So now I'm to moles of CH4, and then I would have multiplied that times the molecular weight, which is 16 grams per mole CH4. And that would equal 133.6 grams of CH4. So that's the way I would have done the problem, without being in this part of the chapter. The mass, you can do it by mass percent, right? Or you can do it by mole. Either one. Either calculation is valid.
If they just ask, if that's what the question asks, how many moles,
I would just, if you asked how many moles, then I would stop right there.
What if you did the other way, you take 1.33 divided by 16?
Yep. So any of those work. Yep.
Can you go to the next slide?
Yeah.
Where do you get, so I get where you get the first 100, because it says it in the problem. Where do you get the second 100?
Because that's the relationship for, you could have done that. I calculated the fraction right here. I could have used 1 over 0.7485.
And you multiplied it by.
So that's just giving us that fraction, right? And so either way, I just did it the way it was on the board. To me, you work back and forth between those mentally.
Could you have just used 16 over 12 instead of calculating the fraction?
We did use it right here.
Yeah, but I'm saying instead of calculating the fraction, then using that.
You could have, yeah, just set it right there, 16 over 12. Yes, ma'am. Mathematically, that would work.